Hello, my name is Eric Sondy, and I'm here with my colleague Jason Andrews, and we're going to tell you about how to get started with ARM IP Explorer. To start, I'm going to tell you a little bit about what exactly ARM IP Explorer is. ARM IP Explorer is a new cloud-based SoC development solution from ARM, created to accelerate IP selection and SoC design. ARM IP Explorer helps the SoC architect explore, design, and share. With IP Explorer, you can increase efficiency and productivity, getting started quickly with easy access to all the information you need all in one place. You can even simulate different configurations to benchmark performance and discover the best solution for your project. That leads to better design quality. You can further optimize design quality by configuring ARM IP quickly to meet your product requirements, by creating high-level block diagrams of your SoC architecture, and checking the compatibility of the IP in your design, and by getting expert advice from ARM's field application engineers. More efficient collaboration with ARM and ARM-approved design partners, along with the ability to easily export the artifacts of your design, like IP lists, system diagrams, and simulation results, can greatly reduce your cost and your time to market. Let's briefly walk through the features on the platform and their benefits. Discover, search, and compare features make it faster and easier to find and compare ARM IP without searching through multiple disparate sources of information like ARM developer web pages, marketing slides, and technical reference manuals. ARM IP Explorer brings all of the information you need all in one place. Configuration, simulation, and canvas features accelerate the initial design phases for SoC architects looking to evaluate, select, and configure the right IP for their projects. Projects are used to collaborate with colleagues, construct block diagrams, save IP configuration options, and store simulation results. ARM IP Explorer is a new way to start SoC design with ARM. Now over to Jason Andrews for a demonstration of ARM IP Explorer.
Thanks, Eric. Hello, everyone. I'm Jason Andrews, and I'm excited to share with you today a new product that we've been working on called ARM IP Explorer. It's a web application which allows IP architects to gather more details and information about ARM IP for their upcoming projects and to start to sketch out their design. So today I'm going to provide you a tour of the platform and show you the primary features so we can analyze it and learn about it and find out if it's something that you're interested in trying out. So we'll take a look at some different ways we can discover ARM IP, as well as configure it and simulate it. And I will show you how to do that. So first of all, let me just say you can reach ARM IP Explorer from our developer website. So that's developer.arm.com. You'll see there's a link here on the top, which is called ARM IP Explorer. And that's one way to get there. The other way to get there is just to go straight to the URL, which is ipexplorer.arm.com. So if you just go to ipexplorer.arm.com, you'll reach the platform. Now, if you don't have access currently, you might be met with a request to have access. And the way the platform works is you use your ARM account. So if you have an existing ARM account, you can use that to log in. If it doesn't work and it says you need access, then you should fill out the form to request the access. And then somebody will take a look at your request and review it and then grant you the access based on that. So that's how you reach ARM IP Explorer, either from the developer website or from the URL ipexplorer.arm.com. Okay, so with that, let's start into a little bit of a tour of the platform and I'll show you some of the features. So the first thing we're going to take a look at is discover CPUs. So if you're kind of new to ARM and you want to find out what might be the right place to start looking or which type of CPU would fit for your application, you can use this wizard. We call it Discover Wizard or Discover CPUs. And the first screen essentially is presenting with you some options, whether you're looking for an application processor, a real-time processor, or embedded processor. Essentially, it's mapping to the Cortex-A, Cortex-R, and Cortex-M family of CPUs. And then you can read the short description and pick out the use cases that might be similar to yours. Maybe you can identify with something on the list. For this case, let's consider maybe we're looking at an embedded microcontroller. So we'll select embedded. And the next question is asking about your priorities based on power, performance, and area. So you have three choices there to work with. Again, high performance, more of an efficient or balanced power and performance, and then the low power area spot. So let's just pick the efficient and balanced for this particular demonstration. And then there's a couple more questions asking if you're interested in enhanced security, machine learning, that's like vector instructions or digital signal processing type instructions to improve the performance. And we can leave those at the default and say yes and yes for both of those. Now what we're presented with are some results of the wizard. So it's explaining that the Corestone 300 system is going to be a great place to start if you're interested in that. Seems like a good fit for your application. And then there's a couple different CPUs down here which are recommended. So the Cortex M55 is going to be the top recommendation with a short description about that in the block diagram, or the Cortex M33 is also a good possibility. You might want to take a look at that one. So that gives you a rough place where to start. If you're coming in new, you don't know a lot about ARM IP, there's many different types of CPUs. This gets you in the ballpark fairly quickly, and you can have a look at those. Now on the bottom, there's ability to compare those processors or add to the project. So you can go ahead and do that if you want to. But for now, what we're going to do is buzz back and show another way to find ARM IP, which is by the search screen. So here on the search screen, you have all of the ARM IP listed. You see there's 284 results which are available. There's filtering on the left side if you want to zero in on a certain type of IP, processors, interconnects, some system IP. But for the course of this demonstration, I'm going to show you a little bit more in the Cortex M family that we just went through in the Discover application. So one of the things you can do here is click on the name of the IP. So Cortex M55, let's take a click on that. And what we'll see are some IP details that might help you get a better understanding, better background of what this CPU is all about. So we have the block diagram on the left side. Then we have a description, which gives you more information here. Then we have some links to the technical reference manual and material on our developer website. And probably the most interesting thing here are additional product information that you won't find on the public arm.com or developer.arm.com websites. So one of the big benefits of IP Explorer is you can get more information than you can get otherwise, and you can do it by yourself on your own time when you're interested in looking at these things. So no need to contact ARM, no need to submit any support cases. You can just go in and find out more information. So let's take a look at the choosing the right Cortex M presentation. And what you get here is essentially a PDF file, which is a presentation about a particular topic related to this IP. So this one is about choosing the right Cortex M. As we mentioned, we might be looking through different Cortex M. We kind of got a feel for the M55, or maybe the M33 is a good fit for our application. And then we can page through these things to try to figure out, okay, where does this fit? What are my options? What are the differences between the different Cortex M processors? Now you see in the performance and efficiency row, we have the M55 there, we have the M33 there. Both of those are encapsulated in the trust zone outline because in the Discover app, we selected security was of interest to us, but there are other choices. There's a Cortex M7, which has a higher performance. There's a Cortex M23, which is going to have lower power and area. So you can kind of browse through these. Again, there's 54 slides here. You can go through and learn more about this particular IP and where it fits in the portfolio. So that's a great resource. I would encourage everybody to take a look at those product informations that are listed on the IP details page for each particular IP. There's some other stuff here about licensing. Is this IP part of flexible access? And then there's some PPA points down on the bottom. So if you're interested in the smallest area on a 40 nanometer process and you want to take a look at some of the data for power, frequency, and area, you can do that. If you want to look at more like the max performance configuration of the Cortex M55, you can see those here as well. So, general useful stuff about the IP that you can find out from this IP details page. Another thing which is useful from the search page here is a comparison. So if we select the M55, we can select the M33, and then we also saw the M7 was the higher performance processor. When we looked into the PowerPoint, we can select that one. and then we can compare those. Now, when we compare them, we get a 3-column layout, which has each one of those CPUs across the top. So the M55, the M33, and the Cortex M7. And then we can kind of scroll down side by side and do a comparison of what's the same and what's different. So we'll see the block diagrams, and then you'll see the yellow or gold highlighting here, identifying where there's some differences. So we can look at the AMBA interfaces which are used on each processor. We can look at the versions of the architecture. You can see the Cortex M7 is the ARMv7M architecture versus the ARMv8M and the ARMv8.1M for the Cortex M55. You see the pipeline stages, whether or not it has coprocessor support or custom instructions. So there's a fairly long list of things that you can scroll down as you go through this and look at the benchmark data, different kinds of TCM, tightly coupled memory, which is available, or caches, which are available. So it's a good way to compare maybe 2 or 3 CPUs side by side and then have a look at that. And you can certainly change those at any time. So if you want to switch out the M7, maybe go to the M23 instead, you can just change the drop down here and then scroll down through the Cortex M23. So that's a good way to compare the different processors, get a handle on what's the same or different. Okay, next thing we can look at is how to configure the IP. So I'm going to select the Cortex M55, and you'll see there's a configure button here at the top. So what this allows you to do is get a good idea about the configurable options for this processor without having to open up the technical reference manual or the configuration and sign-off guide, or download the RTL bundle and start looking through the scripts and the code of the processor. This is a way you can get a good handle on all those things very quickly, just right here in the web application. So when I open up the configure for the Cortex M55, you'll see down the left side multiple categories of options which are available. So the first one is your maths and DSP. Whether or not you want the floating point unit, you can look into the security extensions if you want to have those on or off, and how many SAUs to include. Cache and memory is a good one. So you can see the cache sizes are configurable on the Cortex M55, so you can select different cache sizes here. And essentially all the things that are configurable in the RTL are exposed here for you to work with through the browser, and then make sure that your configuration is a good one. So there's a check button here, which will check your configuration, make sure everything is working. There are no values which would contradict each other or are not possible. For the most part, all the parameters are checked, and make sure they all are correct as you enter them here, but it's good to make a check on the configuration to validate it's a good configuration before you go any farther. So this is a good way to configure the IP, and you can browse all the details of the Cortex M55 here. You can do the same thing with the Cortex M33. So if I wanted to have a compare and contrast about its configuration options, I can open up the configure for the Cortex M33, and you'll see similar tabs down the left side about the mass and DSP instructions, the memory regions which are available, different kinds of interfaces which are available if you want the coprocessor or no coprocessor, so on. So that gives you a good picture of the configuration details for both of these processors, and you can get a handle on what's possible. So let's say in this case, I want to take the Cortex M33 and I want to add it to my project. Now, project is really a grouping of IP that you kind of bundle together with the goal of kind of laying out a proposed SOC design where you're going to try to build towards a diagram and an IP list and kind of assemble the things necessary for your particular project. So think of it like a concept of an SoC, and you're going to start grouping and bundling the IP together. So in this case, I'm going to add the Cortex M33 to the project, and I can select an existing project. In this case, I have microcontroller 12, or I can add it to a new project. So if you drop down, there's a create project as well. So however you want to do it, you can add that to the project. So I'll push add to project, and then it will save this in the list of considered or interesting IP for me to do. Now on the top here, we have the My Projects. Let's just jump over to the microcontroller 12 project and have a look at some of the things that are in there. So on the project homepage here, there's a bunch of information which will help you maybe check out some different product information, some suggested IP that goes with it, some more details about your project itself. But what we're going to end up with is kind of a list of IP that we want to cover and some of those details. So here I've started building a list of IP for the project, some different processors I'm interested in, interconnect, such as the NIC 400. I have a DMA controller in there, some different memory interfaces. So I'm building up this list of IP, which is under consideration for my next project, let's say. Another view of this is by way of the canvas. So on the canvas, we have a way to kind of start sketching out the diagram of the system you're considering. So, in a lot of cases, IP architects or design engineers will go to the whiteboard, draw some boxes and lines on the board, and start to get a feel for how do these things fit together, start trying to explain the concept of the project to the other engineers involved. Right, so here I've sketched out a project with the Cortex M33. I hooked it up to an interconnect. I have the DMA controller. Maybe I have another IP, the random number generator associated, maybe some memories, different things. You can start to sketch out the project on the canvas. Now, there's a couple of useful things on this canvas which make it a little bit unique compared to doing this on your whiteboard or in a generic block diagram type tool. And that's really the details of the IP itself. So if I click on the Cortex M55 here, you'll see I have the ports described, the width of the address, the width of the data. So I get a little bit of smarts on the boxes that are specific to that IP. And as you configure the IP and save those configurations, it'll update these block diagram capabilities. It'll show you that as if you change the data width, and the data width will change back here in the canvas as you go through the project. So it gives you a little bit of a context there. Now, the other thing it does is, let me take the M55 off. There's a way to check the system. So in this case, I'm going to disconnect the processor from the interconnect and then push check system, and then I will get a validation error. So essentially what's happening, saying if you don't connect the code port for this processor, it's not going to run any instructions. That's going to be a bad situation. So you probably don't want to do that. So you get some validation of your diagram to make sure that it's sensible, and then you can check the system and see that it's valid now if you do that. So that gives you a way to kind of lay out the boxes, the lines, group your IP together, share the project by way of the canvas with the other engineers in the project. Another way you can collaborate is here on the collaborators tab. So you can add collaborators on your project who are other users within ARM IP Explorer. So if you know their email address, most of the time this is likely people in your company. It could be from a design partner that you're working with, or maybe some consultants or contractors that are on the platform. You can export this information into their account so they can share or collaborate with you on the project. So this is at the project level, and you can do a read-only collaborator or a read-write collaborator, and then you can add people using their email address. And then what you have is box here. You can check over by typing a message, and can you check my simulation results and how I configured the Cortex M55, and I could send that to the other people in the project, and then that would be a way to collaborate with the other people in the project. So that's another thing that we can do in terms of collaboration. So you kind of can see we're building this model of a project with IP, sketching it together in the form of a block diagram, and collaborating with others. Okay, next feature I want to take a look at is simulation. So one of the key parts of IP selection is going to be able to simulate IP and do some benchmarking and really confirm that a particular processor meets the performance requirements that you have for the project. So this is the simulation setup screen. It gives you a way to simulate IP and really do your own kind of benchmarking. So what we do is we select the system. Let's say we're still looking at the Cortex M55. I'll select that one. And then the project here, I still am on microcontroller 12. This means that the results that I save are going to go into the microcontroller 12 project when I run my simulations. So here we have a small description of the system, which is going to be simulating, and a block diagram showing an M55 with a NIC 400, different types of memories and peripherals on the right side. And then we have the parameters that we're going to use to run. So these are the hardware parameters. So if I click the preset parameters, these are the things that are kind of fixed in the system. So generally, they're things that don't impact performance very much, but they just have to be selected in terms of the processor's configuration to make it run. So, we can look at those, but we can't change those. And the ones we can change are underneath. So here you can change things about the memory configuration, the cache size, the tightly coupled memory, different things there. So let's do first simulation where let's take no instruction cache, and we'll take no data cache. And then on the TCM values, we can leave those as default. And then the memory, the system memory, we have options to make it wider or narrower here, and we can insert some wait states. So if you want to see the impact of memory delays on your simulation results and performance, you can do that as well. And then the last tab are the simulation outputs. So with the simulation feature, we have ability to save a tarmac trace. This is like a big text file with the instruction trace of all the code you're running with the timing. So you can see, any particular details of how your code is executing on the processor and study maybe where the stalls are, where the time is spent. You can do that with the tarmac trace. And then we have a waveform file, which you also can generate, which is going to show you the hardware details on the different interfaces on the AXI bus, what's happening, and where the time is spent. You can generate a waveform file for that. So in this particular case, let's take one of the pre-existing benchmarks. So we have some software preloaded into the platform. So I'm going to select CoreMark as my benchmark, and then you can choose your compiler that you want to use. So let's take the GNU compiler, GCC. There's another provision here to upload your own software that's a custom benchmark. So I could bring my own benchmark onto this platform, run it on this system, and then measure the performance of that. That's a little longer process. I think we're going to save that for another webinar. I can go through and explain how to create your own benchmark and then run it as a custom software on IP Explorer. So for this one, let's just take the standard CoreMark using GCC compiler and add that run to the simulation. And then when I push that, you'll see on the right side, there's like a simulation queue, which is building up. So we can have up to 5 runs that we put into the queue, and then it's going to run those in parallel and then compare the results kind of side by side so you can see the differences. So let's try one more. Let's go back to the memory configuration and make the caches as large as possible, 64 kilobytes. Put that in for the instruction and the data cache, and then let's run the CoreMark again, but switch to the ARM compiler for embedded, or ARM compiler 6 we call it, and add that run to the simulation. So now I have a simulation queue with 2 runs. Estimated time to do this is going to be 20 minutes. Again, you can add up to 5 runs here. And then when you're happy with the systems and the software and all the settings, you can go ahead and push start simulation. And then that will launch a simulation kind of in the background on this particular set of systems and software that we launched. Okay, and those are going to go back into the project under the artifacts tab on the simulation area. Okay, so that's how those things are running. Okay, now as it's starting up that simulation, I'm going to just go ahead and cut to the results so we don't have to wait the 20 minutes that was advertised as the simulation time. So let's go ahead and do that, and then we can see what the results look like. Okay, so I've loaded up the simulation results page for those same 2 simulations that I just kicked off. And what you'll see here is, first of all, the total cycles to run the simulation. So again, if you recall, we had 2 different simulations, one with GCC, one with the ARM compiler. And then we had one where the cache was essentially 0, and one where the cache was the maximum size, which is going to be the one with ARM compiler 6. So you can see the number of cycles is drastically lower when we had cache, which is a good sign. The right side is the total cycles, and the left side is what we call the marked software cycles. So let me explain a little bit what's marked software. So when we do benchmarking, there's a certain amount of code you have to run to start up the processor, get things ready. And then at that point, you want to start kind of counting the benchmark, like start a benchmark. And then when the benchmark is done, you want to stop the counting because there's some cleanup, like gather the results, print the messages on the screen, or save whatever you want to save, kind of the cleanup phase of the benchmark. So that's what we call marked software, is really that key part where we want to measure the benchmark. So we can separate the full run from just the important part by using some markers where we tell the system, okay, start counting now. And then when the test or benchmark is over, we say, okay, stop the counting now. And then that gives you kind of a window to analyze the results. So if we page down here a little bit, you'll see that there's a drop down for each one of the two simulations that we have available. There's a diagram of the system, just reiterating the parameters that we use and the software and the compiler that we use. And then down below are the actual results. So there's a timeline showing the main blue bar. That's the marked part where the benchmark was active. There's also a section which is marking the boot code. In this case, it's very small, just a couple hundred cycles, so it doesn't even show up on the bar. It's so narrow compared to the full run. And then the other is like the cleanup part afterwards. That's not important for the benchmark itself. Then below that, we have the bus activity. So this is going to show the cycles that we were running, some of the read and write activity on the bus, the max latencies, the average latencies, and same for the writes. We've also got some PMU, that's your performance monitoring unit. That's the counters that keep the statistics about what's going on. So we count how many cycles are run, how much were the cycles on the marked part, the important part of the benchmark, some different cache. So this is the one that doesn't have any cache. So you see there's a 0 cache accesses going on there. And it'll show you your average cycles per instruction, which is 4 in this case. So if I switch over to the other one with the ARM compiler 6 and scroll down, you'll see now in this case, we got a lot of accesses to the cache. We got 188,000 of those, and the average cycles per second per instruction, CPI, is down to 1.28. So you see that cache made a drastic difference to bring the CPI down from 4 to 1.28, essentially. So that's some of the metrics that we're collecting off the results. And then on the right side, you'll see that there's a log file for the simulations as it's running. So these are the print statements which are coming on the screen, and then the metrics that are captured associated with the bus activity and different things there. So all this is running really on a Verilog RTL simulation behind this web application. So when you set up the system and configure everything, what's happening in the background is we're running Verilog simulation with all this IP, with the configuration options and the software you specified. It's running behind the browser, so you don't even have to see anything related to that. So it's a pretty cool feature to be able to simulate all different kinds of ARM IP, work the parameters with different values, change the software, bring your own custom benchmarks, and really get the performance analysis that you need. Okay, so that's the simulation feature. Let's jump back to our project, Microcontroller 12. And then if we have a look at the Artifacts tab, some of the other things we'll see there are some comparisons that we saved. You can save those if you want to just take like a save of that comparison app I showed you with the 3 columns. You can save that. We looked at the simulation results. You see the job that I kicked off at the beginning is running now. So you see the progress bars are moving. It's running along. That will finish eventually. And then custom software, if we bring our own benchmarks, those get stored here. We don't have that now. We'll do that in a future webinar. Any configurations you save, you can save those here as well. And then the last one has some reports. So I haven't generated, I have a couple of reports here already, but you can generate a new report at any time with this export project data. So there's a few different reports. You can move the slider here. So these are things like showing the diagram, the IP list, some of the PPA details, your simulation results. It's a nice way to kind of capture all the artifacts that you've collected as you used the platform, and then it makes it easy to kind of share that with other people in the project or with the management or with purchasing. You can easily exchange the data that way. So reports come in the form of PDF files of the overall project. There's also configuration files here for Socrates. So if you have a configured IP and you want to migrate over to Socrates to continue your work, you can download what we call SOC files. That's a file format that Socrates can import and continue with. Licensing information, if you want to share that with your purchasing or other management, you can bring that. And then the last one is design partner services. So there's a way to generate a Word document here, which makes it possible for you to edit that. And then you might want to share that if you're looking at, service providers. If you want to have a design house work with you on the project, you can bring your data that you've generated with IP Explorer and share that with them. So I'm going to cancel out. And then the last thing I just want to highlight is over here on the Design Partner tab, we have a database of companies that are ARM approved design partners that provide a variety of services. So if you are looking for help in verification or software development or front-end chip design or back-end chip design, you can find people in different regions that can help you with that. So lots of features going on here in IP Explorer. Hopefully that quick tour gave you a good idea of how you can search and discover IP, how you can compare and contrast it, how you can configure and simulate it and collaborate with others in your company, and as well as the ARM approved design partners. If you want to go that way to seek some additional help on the project, it's definitely all possible. So again, thanks for the quick tour. Hopefully this helped you understand a little bit more what IP Explorer is all about. And if it's good for you, again, if you want to take a look, please go to the URL ipexplorer.arm.com. If you forget that, go to developer.arm.com and then have a look at the IP Explorer link on the top there. So thanks very much, and I look forward to talking with you in the future.